and welcome to this intelligent briefing. My name is Mrigaya Dham, and in this edition of our deep dive series, I'm speaking with Phillipe Bogaerts. He tells us about the key characteristics of cloud-native security and how security teams can embrace a cloud-native mindset. Hello, can you please introduce yourself to the viewers?
Hi, I'm Phillipe. I'm based in Belgium. I'm a consulting system engineer at FortiCNP, covering EMEA.
What does cloud native mean to you?
Cloud native means to me, so when we talk about cloud native, I think we must understand that this is referring to a new design pattern impacting actually how we build and run our applications so that they are fit and can cope with the dynamics of a cloud environment. This new way of designing an application is typically referred to as a microservice design pattern. It's a very complicated word, I know, but at the end of the day, cloud native applications are actually applications that are built in such a way that they can run and benefit from the cloud services in order to gain resilience, scale, faster time to market, reduce costs, benefit from increased and better security, and so on and so forth. An example would be, for example, why would you currently invest in running your own redundant and scalable databases? Because this requires a lot of expertise, money, and human resources, while you could simply consume a managed database service, and all that work and expertise is actually handled by the cloud solution provider, and so we don't have to do it ourselves anymore. A second example would be, for example, if you require a solution, an application that need to be capable to quickly increase the capacity to accommodate a lot of users during a marketing campaign, for example, and as such provide a way better user experience, because that's an important factor of an application. And when this campaign is over, or we don't need the additional capacity anymore, we can actually scale the application down to essentially reduce the costs and save money. So a cloud native application will leverage all these benefits of the cloud solution provider and make sure that we can use the cloud in an easy and an affordable way. Trying this in an old-fashioned way, I would say, is pretty challenging and very, very, very expensive.
What are the key characteristics of cloud native security?
Securing cloud native applications or workloads, however we want to call it, is a totally different ballgame. First of all, we must understand that security in a cloud environment is a shared responsibility. This means that the cloud solution provider will take care and secure their platform, their networks, their managed services, and so on and so forth. But securing the application that we are going to build and run on top of, for example, our EC2 instances in AWS, that's our own responsibility. On top, that responsibility that is shared between the cloud and ourselves tends to shift depending on what kind of services we use in the cloud. Means when we're talking about infrastructure as a service, PaaS, SaaS, and so on and so forth. So it all requires different sorts of care and attention. Developing cloud-native apps or microservices requires also more than just a cloud. I mean, to do this correctly, we need to implement a totally different culture, typically referred to as DevOps, or even better, DevSecOps mentality. It's way more than tooling. It's a mentality. It's cloud. It's everything put together and make sure this can work. So the solution to solve the security puzzle is often referred to as a shift-left security strategy, meaning that we need to build and assure the security of the things we're building while we are building it, and not really as an afterthought. There is also another very important aspect here when we talk about cloud-native security, and that is cloud configuration and management. While clouds make it very easy to onboard new accounts and run applications, we should still be very, very careful not to grant too much or excessive privileges to accounts, or to simply make configuration mistakes. Yeah. So therefore, we actually need specialized security tooling capable of detecting all these new risks and mitigating all these new threats in this probably new ecosystem for a lot of customers and in that microservices approach. So that's one thing. The tooling does exist, but it needs to fit. And that's an important aspect here, because these new tooling, they should be capable to be integrated and automated in our workflows that will build our applications.
Why does a legacy approach to security not work for cloud native applications?
Let me explain that by an example. We might all have heard about a recently discovered OpenSSL bug. It's commonly available everywhere. So it might impact applications or web applications probably running everywhere, whether it's in public, private, hybrid cloud, or even in legacy platforms in our data centers. The question here is, how are we going to detect and mitigate that new vulnerability in our microservice design or cloud native app, if you want to call it like that? So think about the problems that would arise if you would fix that in the old-fashioned way. Go into the box, fix the app, and let's go. So think cloud native means that your application is probably an application that is built on VMs in a cloud, or is built using containers or Kubernetes spots. And that application is designed to scale up and scale down automatically based on load. Now, suddenly, somebody announces and figures out there is a new bug. How are we going to fix this? We cannot go simply into these containers or VMs and go and fix it, because next time we would create a new instance or scale up or scale down, the problem would simply return. The solution doesn't really lie in fixing the running instances, but fixing the issue in the code or operating system in this case, building and releasing a new image, deploying new instances based on these newly released images, and then destroy the old instances. And all this in an automated and coordinated way.
How can security teams embrace a cloud native mindset?
I think we need to go back to the basics here. So there are good reasons why applications move to the cloud, as explained before, and to fully benefit from these platforms and to be cost effective, because that's an important factor here. Apps should be built with a cloud native mindset in mind, and as such be secured. Let that be obvious. This might be or look very easy in a greenfield or born in the cloud kind of scenario than with existing on-premise or legacy applications. I'm not saying that the latter is bad or less secure. It's a different design pattern that we applied for years or decades. And the problem is it's simply not fit for cloud. That's all. So taking a legacy application, typically referred to as a monolith type of application, and moving it to the cloud, also known as lift and shift quite often, and continue business as usual is probably a very bad idea and for sure not cost effective. Can it be done? Yes, but you lose basically all the advantages. So moving an existing application to the cloud is more like a journey. This means that to fully benefit from the cloud, we'll need to step by step decompose that application and make it more modular to, in the end up with a microservice design, as explained before, that can fully embrace the cloud benefits, and as such become way more cost efficient. During this process, which, as I said, is a journey, security teams can learn and implement step by step a cloud native security program. Security vendors can help you in selecting the right tooling and integrate it in your overall security strategy. At Fortinet, we call this the security fabric.
Thank you so much.